So, welcome everyone. Good afternoon. Can one of you confirm whether my voice is clearly audible or not?
It's very clear.
Okay, okay. Thank you. Thank you. Just let me know if the voice breaks in between, then I'll just switch my video off and move to only audio mode. Okay, regarding the content of week 9, so mainly the course deals with the structure of DMRS signal in the 5G NR framework. So when it comes to DMRS structure here, can we point out, like, if I consider this one as a slot maybe, and this is the time domain, we can call it the number of symbols also, and this is across the frequency domain, of course. So intuitively, before getting into any mathematical stuff, what the DMRS we can expect, like at which position of this slot, because the scheduler has to decide, of course. So intuitively, at where we can send our DMRS signal. Anyone?
So it can be started either from symbol number 2 or 3, depends on the PDCCHL. What is the located PDCA symbol?
Okay, okay. So we have earlier seen that we initial symbols are basically reserved, as you mentioned, for PDCCH downlink control information, and it has its own set of DMRS. Fine. So that may occupy up to 3 symbols. So either my DMRS is going to start from symbol 2 or symbol 3. Fine. And what is the reason for the same? Can you just point it out? Why at the initial stage? Or in other way, what happens if I transmit my data first and at the end I schedule the DMRS? So what is the problem I'm going to face in that scenario? Let's assume that apart from the PDCC's information over first 2 or 3 symbols, rest of the resource elements across the entire slot is occupied by my data only. So I decide to transmit the data first, and at the end of the slot my DMRS is scheduled. So what is the problem I'm going to face in that scenario, and why it is not done in that particular way?
Yeah, because DMR is required to, like, first we have decode the DMRS, then we got to know the channel condition. According to that, it will decode the PDCCH. So if we'll send the DMRS at last, so the PDCCH decode, like, maybe got fell, and you will send that.
Okay, can you just repeat your last sentence once? I missed that part.
So I'm saying, if we sending DMRS at last,
Okay,
so we don't know the DMRS, means the DMRS, we by decoding the DMRS, you got to know the instantaneous channel condition. So if UE will not decode the DMRS, and it will directly decode the PDSCH, then maybe the PDSCH decode will fail, and UE, the most chances that UE will send back from that block.
true, true, almost true. So, like, for you're saying that basically user can know the instantaneous channel from the DMRS, and then it is going to use it onwards for its data detection. But of course the PDCCH decoding is going to fail, fine. But let's say on user side I decide to store all that information that comes before the DMRS, and once the DMRS comes at the last symbol here, I use it to estimate the channel, and then I apply the same on the stored information to decode my signal. So is there any problem with that, or
It will add to processing delay.
okay, it will add to processing delay, fine. Anything else? So basically I have to reserve a large chunk of my memory, right? If I consider the data that is being transmitted here over multiple symbols, and I don't have the channel information for the decoding, I have to store the entire information. So how sending DMRs at the beginning help me resolve the issue? So basically, as you mentioned, there is a, yeah.
The symbols that are received, they need to be stored, because we cannot do anything without estimating the channel. And in order to store the symbols, we require memory. So if it is at the if we are receiving DMRS at the end of the slot, then we need to store the symbols basically, and that will add to the memory requirement, more memory requirement, plus processing delay.
Okay. And what if I transmit it as mentioned in the standards, like at the first, like a second or third symbol? What is the advantage?
Uh, because once it is received on second or third symbol, what it will start estimating the channel, and it will the things will not get delayed for processing.
Okay. And I also need not store, I guess, those all informations, because I can
Yes.
proceed symbol by symbol. That's what you are referring to. Okay. Absolutely true. So this is fine. So fine. DMRS need to be sent at beginning or as initial stage as possible. Good enough. Uh, let's say the user is moving at a medium velocity. I mean, it's not static or moving at very low velocity. Not a pedestrian I'm talking about. Maybe I'm moving about, like talking about a car or something, where the speed is like 40-50 kilometers. So basically we have seen in earlier sessions that that means your channel is going to change more frequently. And so do you think it is sufficient to transmit only uh, DMRS over one symbol in a slot, or there is a provision to send multiple ones?
Additional DMRS option is there. No?
Okay, so you have to transmit additional DMRS, and why the additional DMRS is required, by the way?
So if you'll be sending normal DMRS, then you will be applying all the properties of DMRS through the entire slot. But if you are scheduling some additional DMRS, then within 2-3 symbols, you can do the estimation again and apply for the next 2-3 symbols.
Okay, so you are saying that I have more recent channel information, right? That's
Yes.
what you are referring to.
Yeah, yeah.
Okay, okay,
So after every 3-4 symbol, I will get some new DMRS and I will apply all these DMRS properties to my next PDSC channel to decode the data.
okay. So is there any restrictions on the number of uh, DMRS we are supposed to send per slot? Something of that sort. Like for example, let's say I my PDCCH, let's say have six symbols. It spans six symbols. Okay. Well, by the way, when I say PDCCH, that's a bit wrong notation here. I don't mean to say that. What I mean is that let's say first two symbols are reserved for PDCCH, third one is DMRFs, and let's say another three symbols here. So total it makes 0, 1, 2, 3, 4, 5. So let's say this number is 5. So my PDCCH data is scheduled up to fifth symbol. Can I send additional DMRS here? Let's say at I have already something on the second symbol, something can on fourth, can I send?
So, sir, first two symbol or three symbol will be for PDCCH, or first five symbol you are saying for PDCC?
No, I am saying from the very beginning, like from slot boundary I'm counting, like from like first two, let's
Symbol number 0, 1, 2 will be for PDCCH, right?
symbol number 0, 1, let's say for PDCCH, symbol number 2
Mm-hmm.
is for DMRS, and then you have 3, 4, 5 where your PDSCH data is scheduled. So I am saying for this scenario, can I, like, am I allowed to transmit, let's say, another DMRS at the fourth symbol here?
So for that, sir, 3GPP has defined some table.
Okay.
I don't remember exactly. But that will not be beneficial, na, because you are sending DMRS again and again, and that will be creating overhead, right?
That
And
will create
PDSCH
overhead.
data will be stuck.
Sure, true. So basically standard says this number I'm using 5. So as long as this number is between uh, less than equal to 7, so I'm supposed to send no additional DMRS. Any idea about the number where I am only allowed to send, let's say, one additional DMRS? How many symbols
I
should
think
be there?
if the SLIV is between, length of the PDSCH duration is between 7 to 10, if I'm not wrong.
Okay, very close only. It's just 7 to 9. Fine. And in this particular scenario, what should be the location of DMRS? Like one is fixed, you already know. So that is symbol 2. Another one, where should it go?
It will be 7.
7th. Okay. So basically I'm having second and 7th. Fine. What about when I can send two additional DMRS?
It is 11 to 13.
11 to 13. And what are the positions apart from 2?
11. 2, 7 and 11.
2, 7 and 11. And is that the maximum limit I have reached, or there is something more? Like, is there any provision to send any additional DMRS over 2, or 2 is the highest?
A maximum 3 additional DMRS can be transmitted.
Fine. And when it should happen?
If the PDSCH length is means like both will be the same condition. Like earlier, two, wherever two can be transmitted, at the same time three can be transmitted. But it depends on the implementation and UE speed, how fast your UE is moving.
Okay. So when, let's say, I have 3 additional DMRS, so what are the possible locations?
If I remember correctly, it's 5, 8 and 11.
5, 8 and 11. Fine. So this entire discussion we are having here, are they applicable for all kind of DMRS that is being transmitted in the framework?
This is for
For
a
type
single symbol and a type A.
type.
Okay, this is for type A.
Type A and single symbol.
Okay, single symbol also fine. So when you mention that type A DMRS, what are the favorable occasions for which we are supposed to use this particular kind of DMRS? Like basically
So,
just
so before starting of the PDSH, normally it is after second symbol or third symbol. Ju- So just ending after the PDCCH occasion.
okay. So basically you are saying when my PDSCH is going to occupy most of the slot, then I'm supposed to go for type A, right?
Yes,
So whenever we talk about type A, there is obviously something called type B at least. So
yes.
what is type B for?
So type B is normally designed for URLC applications where the arc-ACNAG will be expected in the same slot, and
Okay.
the data will be very less. So the PDSCH length will be also very less. So in that case, wherever the PDSCH occasion will be start at the starting point only, the DMRS will be defined. It's like the first position will be DMRS, and after that PDSCH will be scheduled. So
Okay.
normally difference is like mapping type A and B is for A the starting point can be 2 or 3, but for B it can be anywhere within the slot before symbol number 14 and at the starting point of the PDSCH.
Okay. Fine. So let's say I have a URLC data over fourth to sixth symbol maybe. So at which symbol DMRS we are supposed to place here?
Fourth will be fourth.
Fourth.
Sorry.
And in type B, is there any provision for additional DMRS, or it's just nothing is defined, or maybe low latency, so not allowed kind of thing?
So as the length is less, so I don't think there will be DMRS. Additional DMRS will be needed.
Okay. True, mostly URLC application you will find very less amount of data, but what if the URLC data, let's say, spans over 7 symbols? It's
In
unlikely.
that case,
Yeah, you are saying.
one additional occurrence will be allowed.
Oh, one additional occurrence is permitted. Excuse me for just a moment. Hi, sorry about that. Actually, I have to collect a urgent package, so please excuse me for 2 minutes. I'll be back. Okay. Sorry about that, but I have to go. Just give me 1 2 minute. I'll be back again. sorry about the interruption. So we are talking about when in URLC scenario you are supposed to go for type B, and usually URLC datas are small in amount, maybe accounts for one or two symbols, but even if they can go to seven symbols, so in that scenario one additional DMRS is permitted. Fine. So basically we are talking about type A and type B kind of DMRS here. So let us introduce a slide. So we have type A and type B DMRS. So is there any subdivision for each of them? Like, can they be further classified in something else?
Yes, they can be classified into type 1 and type 2.
Okay. So we have type 1 and type 2 for both the scenarios. Okay, before moving into type 1 and type 2 here, there is this, as of now we have talked about single symbol DMRS, but sometimes in the course we have seen the presence of double symbol DMRS also. So can one of you point out what is the need for that? Like, why should we even go for the double symbol DMRS? Any particular scenario where it's required?
Normally, whenever you have a less number of antenna array, so you can use type A, sorry, single symbol. And when you need to transmit with a large number of antenna array, in that case, you have to use double symbol DMRS so that DMRS ports can be assigned.
Okay, so you are
More number of DMRS ports can be assigned.
so basically you are saying when you have more DMRS ports to sound, you should go for type 2. And by the way, how it is going to help when you use double symbol DMRS, when you have more ports, of course. I understand your point, like there are like certain scenario you have more DMRS ports, so then you are saying you should go for the double symbol, fine, but how is that going to help me exactly?
Uh, because you have limited number of resource in time domain and frequency domain with respect to ARV. So to further divide them, you need to divide them into like virtual antenna ports. So that's why you need to assign different DMRs to different antenna ports, so that each antenna ports will be pointed towards a particular DMRS, and that DMRS will be behaved as per that antenna port.
Okay, so basically you are saying like if I plan to sound more orthogonal DMRS port, I need more resource elements, and that's why we are combining over them in a symbol domain
Yes.
to increase the number of resource elements. Okay, fine. So what about this type 1 and type 2 here? So let's talk about type 1. So in type 1, how many orthogonal DMRS ports can be sounded?
In type 1, for a single symbol, 4 orthogonal DMRS can be sounded.
Okay. And what is the structure for that? I mean, you are saying about orthogonal. So in which domain you are supposed to create that orthogonality?
In frequency domain.
Okay, in frequency domain, fine. And how do we achieve that?
With OCC, orthogonal code cover.
Okay, fine. Orthogonal code cover is there. So you are mentioning there are like four orthogonal DMRS like reference signal can be transmitted, and then you also mentioned about OCC or orthogonal code cover, and you mentioned that orthogonality is in frequency domain. So fine. So in frequency domain, let's say this is 0th subcarrier and this is second subcarrier. If I transmit, this is one reference signal, this can be another. Okay, fine, frequency domain. But is the orthogonality is only across frequency domain? Like I don't see here four orthogonal reference signal, I can see only two here. One is this, another is this. So I'm in a bit of doubt like how to create orthogonality in frequency domain. Basically get four orthogonal reference signals just from orthogonality in frequency domain.
Sir, there is another concept now, CDM group, group 1 and group 2. So using that, you can create another two things. No?
Okay, so when I mention here 0th and second subcarrier, that means I'm operating over kind of even subcarriers.
Right.
And you mentioned that something like CDM group. Okay, so let us call CDM group 1. So when you talk about CDM, by the way, in which domain we are talking about? Frequency domain, time domain, or something else?
So that is, I think, a different domain, code domain. Means I don't have clear idea about that.
Fine, code domain. So of course you mentioned CDM group, let's say this is 0, then of course there is a CDM group 1. So how these CDM groups are different?
They are transmitted from different antenna ports.
True, fine. So let's say I was willing to sound different antenna ports. So let's say this is 1000, this is 1001, this is 1002 and 1003. Fine, that's okay. Like we are transmitting from different antenna ports, like four antenna ports. But what about like the difference between CDM group 0 and 1? Like are we going to transmit them from same subcarriers or different? Because if we transmit them from same, there is overlap, like orthogonality won't be there. Yeah, true, like there are four antenna ports, fine, we are transmitting them from different antenna ports, we are transmitting different orthogonal reference signal. But let's say from 1000 we are already transmitting this over uh, 0th and second subcarrier, and from 1001 let's say I'm transmitting this here, and from 1000 I'm transmitting this. So what I'm supposed to transmit from 1002? Let's say I'm again planning to transmit this only. So am I you going to use same subcarrier here? Because if I do use same subcarrier, then there is overlap, so there is no orthogonality. They are interfering with each other.
I think here we can use double symbol.
Double symbol, okay, but that is we'll come to that. But as of now, we are talking about since type 1 single symbol, and we have already know that we can sound maximum 4 ports, so there should be some combination here which allow me to transmit 4 orthogonal reference signals. So I'm just trying to see how I can achieve that from here.
It can be both in frequency and code domain. Only
Okay, so
then
you
we
are
can.
saying orthogonality in both frequency and code domain. Fine, orthogonality and both frequency and code domain we are going to exploit. And how do I achieve that? Because code domain orthogonality I can understand from here, because I am transmitting plus plus here and this is plus minus. So this one is what I would call code domain orthogonality. This is what I am calling code domain orthogonality. Even if they are transmitted from the same set of subcarrier, 0th and 2nd, they are orthogonal because they are separate in the code domain. Fine. How to do that frequency domain orthogonality? How to get that? Here I am transmitting from even subcarriers, 0th and 2nd. Is there any way I can transmit from some other subcarriers? Maybe like the odd ones? Like what happens when I transmit from, let's say, first and third subcarriers here? So these are like odd subcarriers. Now are they going to be orthogonal? All four of them, like mutually? Let's say 1002 antenna port transmit this and 1003 transmit this here. So we have essentially four reference signal, 1 2 3 4, but are they orthogonal? So if I see inside one CDM group here, one CDM group, the elements are going to use same subcarriers, so frequency wise there is no orthogonality. But inside one CDM group there is code domain orthogonality, that the codes are going to be orthogonal. So even if I am even if the, let's say, this port 1000 here transmitting plus from 0th subcarrier and plus from 2nd subcarrier, and the 1001 transmitting plus from minus from 0th subcarrier and plus from 2nd subcarrier, they are still orthogonal because they are exploiting code domain orthogonality. There is no frequency domain orthogonality inside one CDM group. But the moment, and this is about intra group, but the moment we talk about inter group here, like some elements of CDM group 1 and CDM group 0, we can see in code domain they are not orthogonal. Maybe like this one here and this one here, that is from 1000 and 1002, they are transmitting code domain wise, they are transmitting the same thing. So basically there is no code domain orthogonality, but they are transmitting from different subcarriers. Like the port 1000 uses 0th and 2nd, whereas the port 1002 uses first and third subcarrier. So there is no code domain orthogonality, but there is frequency domain orthogonality. So that's how we are creating here four orthogonal reference signal, and here we are exploiting orthogonality in both frequency and code domain. So no matter which pair we pick, they are going to be either orthogonal in frequency or code domain, or both. But we are happy with having orthogonality in at least one domain, then we can separate them. So that's how we are able to create four orthogonal reference signal in case of type 1 single symbol. And by the way, we just saw about use of double symbol. So if I go for double symbol here, how many different reference symbols can be created? For type 1 we have seen, for single symbol we have four orthogonal signal. Now if I am moving to double symbol, then how many orthogonal signal I can have?
8.
Okay, 8. how we can achieve that 8 here? Is there any other domain that we can exploit or which comes into picture so that your orthogonality increases from 4 to 8? Like we have a frequency and code domain orthogonality, that is 4 for single symbol. Now you are saying for double symbol I have 8 such orthogonal reference signals. So apart from frequency and code domain, is there any other domain in play?
It will be time.
So time domain. So you can generate orthogonality across the time domain, which basically refers to symbols. Fine. Now when it comes to type 2 here, what are the differences from type 1? Can we sound like have more reference signal or less? In single symbol we can have 4 for type 1. When it comes to type 2 single symbol, can we generate more reference signal or less than that?
More reference signal.
No, it is 12.
And what is the number?
12.
But we are talking about single symbol DMRs, right? For single symbol it should be 12 or
For single symbol it is 6, and for double symbol it is 12.
so for double you are saying we have 12, for single we have 6. So just now we have seen for type 1 what is the procedure to create orthogonality in frequency and code domain to generate 4 signals, and now immediately we are seeing 6 here. So how we can generate 6 reference signal using type 2? I mean, when it comes to structure, what is so different about type 2 and type 1 so that we can able to create 6 orthogonal signals here?
Type 1 is no repetition along the frequency.
You are saying like in type 1 there is no repetition along the frequency.
Uh, Type 2.
Okay, type 2. So you are saying there is no repetition across frequency, right? So if I
Yeah.
just try to draw for a single symbol, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 subcarriers we have. So what is the structure for type 2? Let's, of course, if you are talking about 6 orthogonal signal, there is 3 CDM group. If I assume CDM 0, CDM1 and CDM2. So what is the structure? Is there any gap? Like for example, type 1 we talked about transmitting from 0th and 2nd. So alternative, there is a gap between. Is there any gap in case of type 2? So type 2 is for CDM0. Let's say we are transmitting two subsequent carriers. Basically we are using these two. For CDM0 we are using these two, and there is actually repetition, but only after here again. Similarly CDM1 using these two neighboring subcarriers. And CDM3 uh, CDM2 is about using these two. So now side by side I will try to draw uh, for type 1 just for comparison. For type 1 we have seen, let's speak for any CDM group, they are transmitting, like there are, we consider two groups, CDM0 and 1. Let's talk about CDM0 only. So there we have seen it's transmitting only from even subcarriers, right? So 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so CDM0 we are talking about, so we are transmitting only from even subcarriers, so that means I am using this, 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 and this. So what is the difference between type 2 CDM0 here and type 1 CDM0 here? Can you point out from graphically? By the way, when you mention type 2 CDM0, you can basically forget this purple and blue, because purple corresponds to CDM1 and blue corresponds to CDM2. But when it comes to CDM not CDM0 for type 2 and type 1, is there any difference you are able to see? Okay, let me just separately draw so that it's easy for you to recognize it. So let's say this is type 2 for CDM0, and so CDM0 basically I am seeing two neighboring subcarriers, and again we'll skip that, and here. So basically we are looking at one PRB only, that is 12 subcarriers, and that's pretty much it. So what is the difference between type 2 here and type 1 here? Like which one is more dense or which one is less dense, something like that you can see. So actually you can see that type 1 is the payload density is higher, because out of 12 RDs you are using 6 of them, whereas in type 2 you are using only 4. So the payload density in frequency domain is less for type 2. So type 2 basically sacrifice the payload density in frequency domain, and what does it gain basically here? So you can see earlier you can only have CDM0 and CDM1 for type 1, and therefore you have 4 reference signal. But here, for this kind of structure, for you have neighboring subcarriers, 2 subcarriers, you have CDM 0, 1 and 2, that is 3 groups. So in terms of code domain, there is the orthogonality of 2. In frequency domain, orthogonality of 3, because you can have 3 separate group of non-overlapping subcarriers. So that's how you are able to generate 6 orthogonal reference signal for single symbol. Of course, that would translate to 12 in double symbol DMRS. So the one crucial difference between type 1 and type 2 is here. Type 1 is more dense in frequency domain, type 2 is less dense in frequency domain, but type 2 basically sacrifices the frequency domain density here, but it will have more orthogonal reference signals. So next, let's talk about CSIRS a bit before moving into assignment questions. So when it comes to CSIRS, we have already seen that just a moment. Uh, Hi, you have a question, Dennis?
Yes, I had one in the chat box.
Okay. Chat box. So you're mentioning that why are the antenna ports number from 1000 and Lucas sir already answered for that. Okay, to help distinguish DMRS ports from other type of reference signal. And well, you are not happy with the answer. You are saying intuitively. So actually, when it comes to numbering, I don't have much clarity also, but the thing is, there is no like concept or so. It's more like a standard issue. If one of you knows better than that, can you please comment? Because I don't have much idea. Only part which I understand, it's more about this standard numbering kind of thing. That why the particular choice of 1000. I don't think there is any intuitive answer to that, like some kind of concept or something.
I've also given the port number also in the last chat for all types of signals.
Okay, for DMRS it's 1000 and above. For synchronization block up to 100 to 255. PTA position reference signal 500 to 99 and CSI. Okay, but is there any what should I say? Any key understanding between this numbering, or they are just a standard way of doing? Like I also don't know about that, so just I was asking if you could help me out here. Maybe Dennis, I will look at it later and get back to you. I have your ID also, so I can answer there. But as of now, I don't exactly know that reason behind numbering apart from the numbers just being standards. But if
The numbering is defined in 3GPP.
so, it's more like a standard issue apart from some key concept behind it, right? Okay, fine. I'll look at it in a more details and get back to you. Okay.
Okay.
So when it comes to CSIRS, we have already seen in the previous weeks that one of the main purpose of that is your MCS calculation at user end and feedback. Of course, like channel estimation at the user end, that's there. But is there any other use of CSIRS? This is what we have looked at great details in last to last session maybe. And basically, CSIRS is transmitted from base station end, so that of course it's sent in a recorded manner, so that base station like user is able to estimate the channel or effective channel and feedback the MCS information. But what about like any other uses for CSIRS that we are missing out maybe in the earlier sessions? Any particular use apart from the first one? Okay, I think CSIRS is not discussed in this week, right? It's SRS. Okay. Sorry about that. We are talking about SRS, and when you talk about SRS, it is mostly we have seen the perspective of downlink channel acquisition. So the idea is pretty much we are familiar with. We assume it's operating on that EDD mode, time division duplex. So uplink and downlink channels are almost similar. So basically, user transmit the SRS, base station do the channel estimation, the uplink channel, and it can use the same for the downlink. Fine. Any other use of SRS? Any of you would like to point out? Other than downlink channel acquisition at base station? What about when the user enters the network? Does SRS plays any role there?
Initial scheduling. Initial scheduling.
Okay, so when you mention initial scheduling, fine. So that means base station need to schedule, and it doesn't have any information. Of course, user enters the network. So how does it really happen? Like let's say it's that the user device operates over the entire 100 megahertz bandwidth. So in that case, is the base station supposed to sound its channel over different frequency range via SRS? So it's going to sound user channel over different frequency range. Any other use for SRS, like something similar to one but in a opposite way?
MCS calculation.
Okay, but when you talk about MCS calculation, as of now, we have seen that is done from the base station end. Sorry, at a user end. MCS calculation and feedback. Can it happen the other way around?
In case of reciprocity based pre-coding calculations,
Okay, so like you are
which will go
point, I
from,
guess you are pointing to that scenario when user have multiple antennas, and we are
yes,
talking about uplink transmission.
yeah.
So basically, here base station is the receiver and user is the transmitter. So user transmit the SRS and base station is supposed to compute the effective rate, or in short MCS, and it needs to feed back to user for further transmission. Okay. And when it comes to SRS, what are the key differences from DMRS in terms of like structuring, or like some key features of its own? Like first, I would like to ask, like DMRS, we always see that it is a kind of initial scheduling, in the sense when it comes to type A, of course, it's going to be symbol 2 or symbol 3. The DMRS is going to be there. And for type B, whenever the PDSCH allocation starts, the first symbol is the DMRS. Is the same happen for SRS or something else?
SRS always send at end of the uplink slot.
Okay, can you please repeat once?
So like DMRS is signaled before the data, but SRS is always sent at the end of the slot.
Okay,
So that G
so
node B has the latest channel condition, updated channel condition.
okay, so you are saying SRS is sends towards the end of the slot. Fine. Is there any specific position we are looking into, like when you say end of the slots, can it be more specific?
Yeah. Uh, so its duration can be four symbols, but allowed positions are starting from sixth symbol to end of the slot. Like sorry, in the last six symbol.
Okay, so you mentioned that it uh, can be anywhere in last six symbols. Fine, one thing. And second thing you mentioned, there is, it can span over four slot. So is it necessary that it
Four symbols.
yeah,
Four
four
symbols.
symbols? So is it
Maximum
necessary?
duration is four symbols.
Okay, so you can say like basically 1 2 3 4 all are possible.
Yes.
Okay, it can span over maximum four symbols. Fine. And anything else, like something key about the structure of SRS? Any?
Normally we call it as a comp structure because it can have like uh, in frequency domain it can be separated with some offset, frequency offset. And that's why we call
Okay,
it as a comp structure, combination offset.
okay, fine. So you are having some comb structure, good enough. And does this structure allows something, like it facilitate some features, like the SRS being of this comb structure? Is there any, like for example, multiplexing of some kind is possible?
So you can multiplex multiple UEs in the same time frequency resource. Yes, PRV will be same, but as per the combination offset, you can allow multiple UEs to
So
send
basically
the
you are saying I can vary the offset and thereby I can multiplex multiple users.
Yes.
And let's say I pick two example. One is this okay, by the way, when this comes to comb structure, what is the gaps allowed? I'm not talking about the offset part. Offset, of course, this corresponds to PRB boundary. This comb structure, the gaps, like can they be any number, or that is some specific numbers that are defined? Like SRS is going to appear in any subcarrier, or let's say if you talk about one PRB, um, and if offset is, let's say, 0, then can SRS appear at every subcarrier, like first, second, third,
Sir,
fourth?
there are two type of combination offset, na, either N2 or N4. So in N2 case, there will be gap of two subcarriers, I think, and N4, I think there will be gap of four subcarriers.
Okay, so one is N2 and N4, fine. Let's say I'm using a particular SRS over, let's say, one symbol with a gap of 2 and offset is 0. And another scenario I am using is one symbol and gap of 4, offset again 0. So how many users I can multiplex in both the cases?
So in first case, I think location will be 0, 2, 4, 6, 8, 10, 12, 6.
Okay,
And in second case, there will be three possibilities.
so let me just talk about this one PRB here. Okay, fine, let us get to the assignments, otherwise it is getting bit late. So yep, about the first question here, that what is the minimum number of OFDM symbols that should be scheduled for PDSCH signal so that we can transmit with three additional single symbol type A DMRS? We are talking about single symbol type A DMRS only, and I am supposed to find the minimum number of OFDM symbol with three additional DMRS.
Yeah, 13.
Okay, 13,
It,
correct.
it is 12.
Is that 12 or 13? Because if I remember, it's 13 only, right? Or when number of symbols are 13 and 14, then only three additional DMRS. So can you please verify once?
So the 12 is also allowed, na?
Mhm.
The symbol location will be L0, then 5, then 8, then 11 for mapping type A.
Yeah, but those are the position of DMRS, right? I
Can,
mean,
can I share my desktop?
yeah, yeah, sure. Just a moment. Is there any?
Yeah, I want to refer to the table.
Okay, okay, sure.
This is the table.
Sir, minimum duration is 12, na? Because for 12 symbols, there are 4 symbols, right? L0 plus 5 plus 8 plus 11. Now for
Okay,
mapping type A,
okay,
right?
yes. Minimum symbol is 12. Okay. Yeah, I was wrong. It should not be 13.
So 12, 13, 14 all are allowed,
Yeah,
right?
12, 13, 14 all are allowed, but we are supposed to go with the minimum. So it is not 13, it is 12. Thanks for this. So, what about this question here? Maximum number of DMRS port that we can configure. Type 2 single symbol DMRS.
It is 6.
It should be 6.
1000 to 1005.
What about this question here? Like user is initially allocated a DMRS configuration with no additional DMRS. Okay, and PDSCH are transmitted with the code rate of R1. Now my DMRS configuration changes. I have to include 3 additional DMRS symbol. Other parameters remain same, and I have this new code rate R2. So which one of these holds?
R1 will be less than R2, no? As the DMRS is more.
And how we are getting there?
So I'm saying like suppose I have 12 symbols as of now with single symbol DMRS.
Mm-hmm.
Later I have added 3 additional DMRS. So 3 3 is a 9. So I have to whatever the total number R is in first case, I have to deduct additional 9 from there, na?
Okay, so that's one way of looking at it, but let's say we are talking about code rate, right? So what is code rate here basically? So we can write it as some ratio or something. So basically if we write, let's say I'm writing it as number of data bits that is divided by number of sequence element allocated for PDSCH transmission. So the I can call it as code rate, right? So this is the number of my actual information bits, and this is the number of bits I am supposed to transmit. So you can see it as a number of resource element allocated for PDSCH transmission. So here it's mentioned that your DMRS configuration only changes, but no other parameter hasn't changed. So based on this expression, what we can infer here?
I think this is confusing because when there are no additional DMRs, the denominator is higher.
Okay, so let's we talk about the numerator
That's why
here.
I'm confused here.
So this number, let's call it m. So the scenario when there is only one DMRS, one DMRS, there is no additional DMRS. Let's say my number is m1, and then when there is additional 3, that is in total 4 DMRS. I have this number m2 here. So what about this m1 and m2? Are they like m1 greater than m2 or m1 less than m2, or
M2 will be greater than M1. So like M1 less than M2. Same.
you're saying m1 less than m2? Okay, but the thing is, when you have additional DMRS, let's say earlier you have only one DMRS, let's say you talk about one symbol, and now you have four DMRS, basically you have four symbols. So that means number of resource element allocated for your data transmission is less, right?
Yes, yes.
Yes, yes, yes.
So it is the other way around. So in case of one DMRS, you have certain symbols where you are transmitting the data, maybe the fifth, 8th, and 11th. But in this scenario, when you have four DMRS, now the fifth, 8th, and 11th symbols are occupied, and they carry no uh, your useful information. They are only for channel estimation purpose. So the number of resource element for data transmission purely reduces. So if m2 is less than m1, and if it's mentioned that rest of the parameter remains same, so there is no change in my number of actual information bits. So that means my code rate, what it was earlier, it should be less than the current one, right? So third one.
When M2 is less with 4, so the denominator is less. Denominator less means the code rate will be more.
Yes, the
This,
code rate will
this
be
is what
more.
is confusing. I think the denominator will not be resource element, it will be number of bits only. Bits available for transmission
Yeah,
within a resource
yes.
grid.
So let me just change it. Number of bits allowed for PDSH transmission. So now M2 reduces, right? When we have reserving certain symbol for DMRS, the number of bits reduces now compared to earlier. So I have actually the actual information bits that remains same, but now I have fewer bits to transmit them. So essentially my code rate increases, right?
Hello, am I audible?
Yes, yes, you're audible.
Yeah. So if there are more DMRS sent, what does that mean? It means that the knee is unable to estimate the channel properly because there are more errors. So knee is unable to estimate the channel. That's why errors are more. So
Prashant, your voice is very
G-Node P
feeble.
has to send more DMRS so that proper estimation could be done.
Actually, I'm not able to, like, voice is breaking. Is that happening with me only, or others are able to hear? So
We are not able to understand. I think there is a lot of
So thing
background
is, if
noise.
I'll repeat, Am I audible now?
yes, yes,
Okay. So if more DMRs are required at user end,
yes,
so it means that there is poor estimation of channel.
yes,
So poor estimation of channel means SNR is reduced.
yes, yes,
So if SNR is reduced, the code rate has to reduce.
yes.
So R1 should be greater than R2.
True, true only, but I think we are making the things a bit complicated. Like when we mention the rest of the parameters remain same, it's like hypothetical scenario that once we are transmitting only one DMRS, and another scenario we are just sending three additional DMRS. If like we want to get into the practical scenario of channel being deteriorating and thereby the error accumulate and the SNR goes down, so therefore that thing, that is true, that is true, of course. But this question is more of a hypothetical scenario that only cares about the two different DMRS configuration, while the rest of the parameters remain same. Your
So why
question,
the GNOB would store, I mean, send multiple DMRs for no reason?
yes, I get that, but uh, like for example, let's say scheduler has already made the decision based on some earlier information that it is going to send three additional DMRS, but it turns out when the users is being scheduled, it has kind of become static. So let's say for that particular slot, whatever the previous channel estimate is there, that is based on the symbol 2, that estimate holds till the end of the slot. So in that scenario, including three additional DMRS symbols is just, you can see, kind of a waste of resources. But actually that since that scheduler made the decision earlier only, so that is the scenario I can really think of here. So the issue is like the question. Important thing is like here we are only focusing on the DMRS configuration, that is the number of DMRS symbols involved, while the rest of the parameters we are assuming them to be same only. Like when rest of the parameters, that means your channel information quality and SNR and the code rate, thereby everything is fixed. It's just comparison between transmitting more DMRS symbol and less DMRS symbol. And like like what you point out is absolutely true. Like if my channel is already good, why should I afford like transmit three additional symbols? That is true. And but that's of a more practical. But in this question, we are trying to capture the understanding that what happens when everything remains constant and we transmit more DMRS, like how the scenario will change. Just we are trying to capture the effect of only DMRS configuration change and nothing else. So yep.
Sir, one question.
Yes.
Like for previous question, there is one question, right, regarding the type 2 maximum port.
uh,
So,
Type
no,
2
not this one,
here.
before that one. So, my question is like, so which table we need to refer for this 3GP table? Any idea?
uh, Document in 3GBP document you are saying na.
Yeah.
I have that ready with me. It is table number 741125 of 38.212.
38212, huh?
212, yes, 38.212.
Okay,
Table
okay,
number 741125.
okay, fine. Thank you.
Okay. I have a question on the previous one.
Here or
Here only.
okay, yeah.
Suppose we have initial four additional DMR symbols and we reduce it to two.
Okay.
What will happen in that case? Will R1 be greater than R2?
In that case, yes, because I will have more resource elements available, like basically more bits available for transmission. And since
Okay.
my actual information bits remain same, then the code rate will drop. Yes. So next is about the statements that are being false regarding DMRS. So what about the first one that comments on the modulation order for DMRS symbol? Is that something depends on MCS index or is that something fixed?
can't be fixed because
Uh,
it is
Sorry, can you just repeat once? I was not able to hear.
Actually, for DMRS it is fixed. For CSIRS it will depend on the time domain, on the MCS index. For CSIRS it will depend on MCS index, and for DMRS it is fixed.
DMRS is QPSC.
Okay, for DMRS
DMRS
it's
is
going to be
QPSC.
fixed. And you have to mention it is a fixed modulation scheme QPSK. So it's kind of a crucial information. So you can see it in this way that G Node B don't want to take any risk. So it's a crucial information. So and user is supposed to estimate the channel. So the modulation scheme used is the lowest possible in standard, that is QPSK here. So this statement is false. So fine. What about the second one? DMRS sequence will depend on slot number and OFDM symbol duration, OFDM symbol location.
This is true because it is slot number 2 and then the wherever it is mapped, the next one.
So you are referring to that gold sequence, right? Where
Yes,
the
yes,
DMRS
yes.
symbols are okay. So this one
So
cannot be
this is true.
this one cannot be false. What about the third one? For Wirelss applications, is type A more suitable?
Th- this is false. Actually, it is type B.
Okay. And about the fourth one?
This is false.
So orthogonality can appear across all time
All
frequency
time,
and
time code and frequency.
okay. So about this question here, we are supposed to calculate the number of REs available to transmit the PDSCH data bits, and we are following PDSCH configuration. So we have 150 PRBs allowed. We have 8 OFDM symbols. So what is the number of total REs including DMRS?
It will be 150 into 8 into 12.
150 into 8 into 12, and that is going to be
14400.
14,400. What about the DMRS? Type A, type 1, single symbol DMRS. That is, it is going to occupy the even or subcarriers, right? If I
Yes.
talk about the PRBs, number of PRBs is 150, and it is going to occupy 6 in each PRBs,
Into two symbols, into two CDM groups.
into 2 there, 2 symbols, and there should be multiplied by 2, right?
Two CDM groups.
Okay. Excuse me, just give me a minute. हेलो भैया. अच्छा भाई आते हैं, बस एक मिनट. Extremely sorry for keep you all waiting. That's a real mess outside. Sorry about that. So okay, we are supposed to compute the number of resources reserved for DMRS here. So that is 150 times 4, that is 600 times 6, 3600. So number of R is available for PDSCH we can obtain as 14400 minus 3600, that is 108, 10,800. So let us move to the next part. So in the it's an extension of question 5 only, but the number of CDM groups now changes to 1. The rest of the configuration remain changed. So what is the number of REs available in this case? For PDSCH is the total number of REs remains same, that is 14400 minus, now we have earlier 150 PRBs, 6 REs, that comes from the type A, type 1 single symbol DMRS. These two here.
Sir, you are not audible.
Okay, just
You are speaking on mute.
okay, just a moment. Am I audible now? So let me just turn off the video once and so am I audible now?
Yes, yes.
Okay, na? Okay, fine, fine. So here my number of CDM groups changes to 1. So 2 here refers to DMRS symbols and 2 comes from the number of CDM groups. And now it should change to 1. So it would be now 150 times 6 cross 2 times 1. That means 14400 minus 1800. That is 120, sorry, 12600. So what is the percentage change here? Earlier we have 10800, now we have 12600. So the difference divided by what it used to be earlier. So this comes out to be 0 16.67% increase in number of RDs available for transmission of data. Now here we are supposed to,
I
yes,
have a question on the previous one.
okay, yeah, sure,
I'm sharing my desktop.
okay.
I hope it's visible.
Yeah, it's visible.
So actually in the previous question, we are talking about a type 1 single symbol DMRS. It is clearly given.
Yes,
So whenever we have type 1 single symbol DRMS, it is defined with 4 orthogonal DMRS. That means by default it will have two CDM groups.
yes.
But in the next question it is saying we have to assume only one CDM group. That is a little bit confusing.
Okay.
Because it's a violation of the standard. Because by default it can't have one CDM group, it has to be two for to have the 4 orthogonal DMRS ports.
Yeah, it's true. So let me just go back to the question once.
Yeah.
Number of CDM groups without data per DMRS symbol. Okay.
Now coming to another important point why am I raising this question. Suppose line number 5 is not given, as it is not given in our assignment also. In that case, we have to assume CDM group as 1 or 2. That is confusing. Because by default it has to be 2, but now looking at the next question which you are showing, I am more confused. Because here it is saying the CDM groups could be 1.
Okay, in
But
the
if
assignment,
line number 5 is not given, then we have to assume it is 2 or it is 1.
by default it should be two only.
By
But
default, it
here,
should be 2 only.
by default it
So
should be
that
two.
means if the number of CDM groups is not given in the question, we have to assume 2 because it is
Yeah.
type 1 single symbol.
In assignment, is there any reference to a 3GB document or something of that sort, or
No,
there
no.
is nothing?
There is
Okay,
no
okay,
reference.
okay. I guess I will clarify this thing once,
Okay.
and I will mention that in the end of the PDF that I will upload. Okay, and I guess that would be fine
Okay.
because I need to clarify that. Yeah, like CDM groups per, yeah, by default it is two, so
Because to have 4 orthogonal ports, we need 2 CDM groups. That is obvious.
yes, true, true. I'll upload this query to this one at the
Okay.
end of the PDF when I'll
Okay.
upload it.
Okay.
Okay. Uh, Thanks for like pointing this out. So here we are supposed to consider a scenario when the moving cyclist is allocated 14 symbols and DMRS type is type A single symbol, one additional DMRS, and of course its by default position is 2. Then which WebDM symbol will have the poorest estimate? Okay.
Which is the farthest away from 2, which is 667.
So yeah. And had this question been a bit modified in the sense there is no mention of additional DMRS, what would be the answer in that scenario? Like here it's mentioned like one additional DMRF. If there is, that part was gone, like this part talking about.
The
The
addition
13.
will be at 7, but still the channel estimation will be poorest.
Okay, so in absence of additional DMRS, you are saying which will be poorest? Can you just,
I think 13.
yeah, like 13 will be poorest, but of course this option has 0 on with that, and that cannot happen, so none of the options would be actually correct in that sense. But yeah, in presence of additional DMRS, it's 6 and 7. This one is the right answer. So you're supposed to find the false statements about SRS symbols. So
In the previous question, if one additional is not there, then what we are saying?
then I'm saying like none of the options are supposed to be correct, because the first this
Yes, yes.
13
Correct.
should be poorest, but 0 is kind of
Ah,
mapped
but
to it
zero,
here.
zero is no way.
Yeah,
Zero is the
of course, that's
very
not
near.
a, yeah. So
Yes.
none of these options are correct. So,
None
yeah.
of the options.
So you are supposed to find the
Somakshi
false.
sir,
Yes.
sir, 0 can be allowed now when the K0 should be not equal to 0. Like if the K0 is 1, so in that case, my DCI will be scheduled in 0th slot and my data will be coming in 1st slot. So in that case, 0 and 13 should be applicable, right? Because my DCI will be scheduled one slot before.
You were saying your DCI is scheduled on some previous slot, okay, and then
In that case, and if my K0 is 1, then and the SLIV is 0 to 13, whole slot will be used for PDSPH. So in
okay,
that case, my DMRS will be scheduled where?
DMRS in
At
that
the
case
second
will
symbol.
uh okay, that is a good question. In absence of DCI, where it should be scheduled. See, as per my understanding, even if uh, my DCI is not scheduled in this slot, some others users is going to be scheduled here only. So my DMRS will still start from symbol 2 or symbol 3. Like, I understand your point. You are mentioning like
So in that case also, so in that case 0 and 13 both will be valid, na? Because what is being transmitted in symbol number 2, I don't know, because my current symbol is 0, right? So I cannot estimate my 0th symbol channel condition using second symbol, right? And while I will be reaching the 13 symbol, the power will be already less, right?
no, but what I'm saying that it's a DCI of other user, right? So when you're talking
Right.
about DCI of other users, and its PDCCH has its own set of DMRS, so that doesn't really count. When you talk about
Okay, okay.
DMRS for me, but it's not others users.
Got it, got it.
So we are supposed to find the false statements regarding SRS. So the first one that says G Node B can use the SRS signal to calculate the MCS for PUCCH.
This is true.
This is true. This is just the opposite of downlink channel acquisition thing we have seen. So just a
The
moment.
second one is false.
So this is true. So second one, SRS can be used to sound a maximum of 2 antenna ports. Okay, it should be 4 here. So it's
That should
false.
be four. Yes.
And then comes frequency domain multiplexing of different RS of SRS of different user is possible. Is that true?
This is true.
This is true because of the comb structure. So this again is not our answer. And 4
This fourth one is also true.
fourth one I guess will be elaborated more on the next week. This week professor just mentioned it. So this is also not an option. So only the second statement is false. And to end this session, the last question is minimum number of OFDM symbols required to transmit PDSCH signal with type B double symbol DMRS. For that, we have to refer to the table for type B double symbol DMRS. If I remember correctly, it was 6 two configuration only possible, 6 and 7, when it comes to type B double symbol DMRS, and of course then the minimum number of FDM symbols is then 6. If anyone has
It
that,
is 6, one,
okay,
yes,
okay. If
1001 to 1005.
so, the minimum number of like I guess in that table I only vaguely remember it. There are only two configuration possible, right? 6 and 7, if I'm not wrong. There was this table shared during the course. Okay, maybe like you can verify for that, right? It's 6 only. Okay, I have little doubt about this answer. I will just cross check once and then update it, but most likely it's 6. 6 symbols at least required.
It is 6 only because I shown the table also. No?
Oh, okay, 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 okay.
The
Thanks.
table number I have given, so we have to refer the same table. 38.212.
Okay, okay.
So,
But I think
so
that
can you
was
go
for
back?
single symbol, right? This is for double symbol. No?
The table includes both single tables, the single symbol and double symbol.
So can you go back to the previous question?
Previous question here, right?
The previous one. No, the previous one.
The previous one here.
Yeah, are you referring to a table?
Uh, can you just repeat once?
Did you refer to a table?
Um, Actually, I'm not getting your question. So can you please write it or?
Hey, my goodness.
So in the meanwhile, he is typing. I have a doubt on one question in the assignment.
Yeah, sure.
So there is a question on. Just give me a second.
Okay,
DMRS
Dennis.
is
Yeah, yeah.
DMRS is used to find the position of the user.
DMRS is
True
used.
is used to find the position of the user, true or false.
DMRS is used to
I think
find the.
position of the user it is not defining. If it had been if the question had been DMRS is used to find the position of the slot, then I think it will be more relevant.
Yeah, what like they mean by position is the position of the user. Okay.
Position of the user means ideally it means geolocation.
Yeah. So if I like translate that part to like position of user to be maybe the channel, but
Only
the
then the word slot should have been used if it is correct.
yes, like DMRS is basically as per my understanding is transmitted to facilitate the user to estimate the channel, not the other way around. So we cannot and DMRS position of user. I think it's no only. And you just mention the question again in assignment.
The the question is DMRS is used to find the position of the user.
Okay.
I think if the word is slot, then it's become more relevant. It could be true, but if it is user, I think it will be false
Yeah,
because
it's
user means geolocation,
yes,
not
it's
not the
it's
slot.
it's going to be false only.
Okay.
So, Dennis, you mentioned that is there a table you are using to come up with the solution? No, actually, in this question, it's not about the table. See, like we have a slot, right? So here it's mentioned you have like let's say 14 symbols are assigned to PDSCH. So if I just a minute. So let's try to draw a slot here. Initial first two symbol you kind of ignore. This is from DCI or PDCCH. This is not of much work for us. This is the second symbol. This is where your DMRS is transmitted, and you are estimating the channel here, and you are using that channel for rest of the slots up to 13, starting from 0, of course. Now the question is like I am using, see, I am estimated the channel using the pilot transmitted here. So essentially this is the channel information for this particular symbol. That need not necessarily hold for all the symbols in the slot, especially when the cyclist is moving. Your channel is slowly changing. Your channel is changing. So the estimate you have that corresponds to second symbol. The moment you move to third symbol, your channel slightly changes, but you are still using this. The moment you move to fifth symbol, your channel changes mode, but you are still using this one. So your performance is going to be slightly bad compared to the third one. And by the time you reach somewhere here, like let's say 10th symbol, your channel significantly changes, and you are still using the channel that is you estimated at second symbol. So your um, performance is really going to be like whatever you are estimating here, like you are not estimating anything here, you are just trying to replicate the channel using this estimate. So, but there is a huge difference between the channel here and the channel here, especially when the user is moving. Now when it's mentioned there is one additional DMRS that is basically coming up, I guess, for 14 symbol at the 11th position, 11th symbol, somewhere here, the next yeah, here. So the idea is to basically when they ask that we are supposed to find the WebDM symbol which have the poorest channel estimate, we have to see as far as possible from where which symbol your DMRS has come. So in the question, if the DMRS has come in the second symbol, you have to go as far as possible to find the maximum change in the channel, and maximum change in the channel and using the same channel estimate is equivalent to saying the poorest channel estimate you have for that symbol. So in that scenario, the 6th and 7th, these are the farthest among all options from the second symbol. So that's why we have chose this 6th and 7th. Is
Okay, one more in the chat.
okay? Yeah, sure. CDM groups without data. So when it comes to without data, of course that means we are like when it comes to CDM group, we are discussing in context of reference signal, and reference signal doesn't contain any information, right? I mean those resource elements kind of reserved for the transmission of reference signal or pilots, but not the data bits. But when you ask exclusively about exact meaning of CDM groups without data, I need to find the exact definition. I'll do one thing, I will also append the answer to the last slide of the PDF that I will upload, okay, and you can find the answer in that place. But if I remember from the class, we have seen that CDM groups comes into picture when we are talking about in terms of reference signal. So there are certain resource element we are reserving for the reference signal that basically doesn't carry any information. So those usually refers to CDM group without data. But for like exact accurate answer, I'll need to see, and I'll update the same at the end of this PDF. So okay, if we don't have any more questions,
I have one question that is related to last week assignment.
okay, yeah.
There is one question where we are calculating four different SNR received at the four antenna of the UAE, and then we need to calculate the NCS.
Yes.
So in that case, the answer was 21. So I'm not sure because the received SNR is like 2.5 dB, and the NCS we are getting 21, that is close to like 22, 23 dB. So like how it is coming that much?
Okay, so let me just open that once. Uh, so I guess like it is the one you are
Yeah.
referring to, right?
Right, correct.
So the SNR we have got something like 5.69, and sorry, not SNR, the
That is
AC.
not SNR, that is spectrum efficiency.
Yes, the spectral efficiency got as 5.69, and what is the corresponding AC for MCS 21? Uh, can you have that, like you have that table now, or okay, like you have
Yeah. So
calculated?
the
Oh, okay.
is correct. Like MCS 21 having this like the four antenna. So is it possible that we can get that much increase in the SNR? Like because corresponding to 21 MCS, if you will see, we will get around 22 or 23 dB.
Okay,
Have you
like
got my point?
okay, okay, you are okay. Yeah, I got it. I got it. So you are saying that like the corresponding signal to noise ratio is very high, unusually high. So just to clarify one point, like the you are saying basically the SNR corresponds to this AC is going to be quite high, and you are asking about its feasibility, right?
Yeah. Means the UE4 antenna is receiving in the combined SNR, how it become 22. Like receive SNR is very low. You can see in the four antenna, like
Okay, okay, okay.
1.5, 3, 2.5, and 2 dB. So in that much poor condition, we will report that much high SNR value corresponding to the NCS value.
Okay, okay, got it. Just a minute. So we have these four antennas here, and we have effective SINR across all of them. AC is coming out to be 5.6 something. That means SNR in the linear scale is of value like 50, and so overall SNR adds up to be 14 dB or 15 dB, something of that sort. Okay. This reasoning as of now I am not having very good clarity. I will need to check it, and then only I can answer for that. I mean, I'd
Okay,
also
okay, sure. Yeah, yeah. You can take your time and just let me know, because I just want to understand whether the calculation is correct or only mistaken calculation. And if calculation is correct, then exactly and practically this situation will, suppose if UE will receive that much less dB SNR, then actually it will report that much high SNR. Practically, I just want to understand.
because when it comes to this MCS index feedback, I remember there is one option we can do this MCS feedback over subcarrier also, and another one is combined MCS, but I'm not able to connect it as of now with multiple antennas. That I will surely check, and I'll do one thing in this week's PDF only. At the end I will like add the reasoning also. Okay.
Okay, sure, yeah.
Okay,
Thank you.
sure.
Yeah, Vijay Lokesh. Vijay, my understanding is that in this case, while we are talking about total capacity, but while referring to the table, it is relative. So that means total capacity, we are assuming that the channel is fully loaded, and that's why it is as same as good as spectral efficiency.
That is fine, Lokesh. I just want to understand, like, if you receive this much low SNR, like 15 dB, then actually it will record that high SNR, like, because if you see the table, so 21 MCS corresponded to 22, 23 dB SNR value. So I'm not able to understand, like, how this much of gain of SNR.
Okay, got it.
Yeah.
But here it is clearly mentioning calculate the optimal PDSCS transmission. The word optimal is very important here.
Yeah, whatever it is, but it will depend on that whatever the received SNR, right?
Okay, got it.
Yeah. Okay, thank you.
And actually the here 5.69 sig will translate into somewhere around uh, 13 or 14 dB, right? Or because if AC is coming out to be 5.7, then the SNR in the linear scale is close to 2 to the power 5.7, that is somewhere in the 45-50 range, and SNR being in linear in 45-50 means in log scale 10 log 10 SNR, that is going to be somewhere yeah, for like 15 dB I guess, 14-15 dB. Okay, I'll check the reasoning and I'll get back to you for sure.
Okay, yeah, thank you.
Thank you.
Sir, regarding matchup,
That one I only observed today that it was not uploaded, but I don't know why. Because last time, if I remember correctly, it is uploaded in the week 8. So I was expecting it would be done in the same only this time. I need to ask them. I will ask the course TAs about that.
okay.
Okay, sure.
So here the total is coming to be 7.56 dB. When I convert this na 5.696 to dB, it is coming to be 7.56 something, and which is less than the sum of the total. That means this is correct because losses will also be there.
You are getting this 7.5. Can you just
I mean,
Full.
but if I calculate total, the total is more than 7.5. That means it is as per the actual scenario, considering the losses.
Okay, okay, okay. Okay, you are adding up the SNRs here, the SNR 1 up to
Yeah.
4. 4,
So that
okay.
means it is automatically calculating the path loss. Path loss it is considered.
Yes. Path loss already considered, yes, true. Okay, I'll still just check the reasoning behind it and upload the same. So, thank you for being here. So,
Okay.
if we don't have any
Thanks.
question, we'll meet in the next Saturday again.
Thank you.
Thank you. Thank you.